Good evening, students. Today we will start the session with unit number 4, derivatives. When we talk about the maths, or when we talk about the point of view of the maths, there is derivatives and integration is the most important chapter, which we are used everywhere. Now, when derivatives word is came, we are using probably dy by dx. Dy by dx means you have to make the d of dx of the y. Means you have to find out the derivatives of the y function. So derivative of the function y with respect to the variable, the function f dash, whose value at the x is nothing but whatever represent this formula. F dash is x is equal to limit x plus h minus f of x upon h approach 0. So it provides the limit exists. Now in derivatives, there are many rules which we have to keep in our mind. Without this rule, we cannot do further solve example. Okay, we cannot solve the example. So keep it in mind, there is many rules which you have to make by heart. The 5 common rule which we are used in the derivatives, that common rule is constant rule, power rule, product rule, quotient rule, and chain rule. These 5 common rule we are used in the derivatives. Not only these 5 rules. More than this, also there are rules which we are using in derivatives. But when we go for the problem solving, the basic step 1 is depend on these first 5 rules. Okay. So constant rule, d by dx c is equal to 0. D by dx x raised to n. Now, when I talk about the x raised to n, you have to represent in nxn minus 1. For example, if there is 3x square, so 3x square means n is nothing but 2. So 3 into 2, that is the 6. 6x, 2 minus 1, that is 1. So we are written there 6x. Next is the product rule. Product rule, d by dx in the bracket f of x and g of x, bracket close. So here we give a function, and for that function we have to find out the derivatives. So d by dx fx g of x is equal to f dash x gx plus fx g dash x. So what is mean of f dash? Here the domain in this slide you can see f of x is nothing but our formula which we are used. The derivative of the function f with respect to the variable x, the function f dash. So when we are find out the derivatives of the x, that is f dash x, we know we are using the function, but for derivatives, whatever the function we are used, that's called as the f dash. Okay, f dash may be smaller than of f. There is no issue about that. So after product rule, quotient rule. Quotient rule means division rule. D by dx, f of x upon g of x. So g of x, f dash x minus fx g dash x upon gx bracket square. Now in this quotient rule, when there is given f of x upon g of x, so simply first of all do one thing, multiplication like g of x, f of x, f dash x minus fx g dash x. This f dash x g dash x means here we have to find the derivative of that. Means g x dy by d by dy x minus fx dg by dy x. Meaning is there you have to find out the derivative for respective variable. Okay, so in this condition, when we go with the quotient rule, first of all, find the derivative of the first numerator, and in the second, like f of x and g of x, so find the derivative of the second term, which present in the denominator. Okay. Next, chain rule, d by dx f of g of x. So in this f of g of x, g dash x. So like this way, you have to find out the derivatives. Don't worry, we'll see the example on base of this. Now, the derivatives of the function. So derivatives of the function, that is nothing but the rate of change. When we go with the slope, when we go with the graph, we know on that graph, when there is a point is go ahead, there is a meaning is there, x value, it change respect to the y. So the derivatives of the function f at a specific value of a x, say a, is a value given by. So f dash a is equal to dy by dx is equal to limit f a plus h minus f of a upon h approach 0. The derivative of a function f as a function of x is called f of x and is given by f of x is equal to dy by dx is equal to limit f x plus h minus fx upon h approach 0. Okay. So we go with the same formula, but instead of a, I'm written here x. Okay, the formula will be the same for the finding out the derivative of the function when there is a is present as a in the value is given, suppose, then we will go with the limit f a plus h f of a plus h minus f of a upon h, and given the condition h approaching 0. When suppose I change the variable and I mention here as a function of x, okay, so x we can say as a variable. So limit f of x plus h, replaced a with x plus h minus f of x upon h approach 0. Now, as I mentioned, you have to keep it in mind, this all function and its derivatives. Like when we go with this c, dy by dx c, okay, then our answer should be 0. Derivative d of dx c is equal to 0. When there is a x is present, you have to write there 1. You have to mention there 1. When ax is present, like d by dx, ax in the bracket is equal to derivative of ax is nothing but only a. A will be any variable, any number. Next, square, x square, d by dx is equal to d by dx x square is equal to. So in this we have to use the formula of this power rule. Okay, in this power rule, what we are saying there, this power rule we are saying here, this n we have to write here first of all, and then we have to write n minus 1. So same thing we are done in that example, in that functions and its derivatives. So here you can see x square, so 2x. First of all, this n, that is nothing but 2, n is equal to 2. You have to write 2x. Now here at this stage, n minus 1 means 2 minus 1. So 2x raised to 1 you can see. Now for the square root. So square root means x raised to half. So half we are taking here. Again same formula. Half x then minus half. Now when there is a derivatives of the exponential, so its value in the derivatives will be the same. Means log e x is equal to ex. Okay. Derivatives of log ex is equal to ex. When there is a log dy by dx, ax is equal to then log a raised to x. Okay. So log a raised to x. Then in again logarithm, derivatives of log x. Here we are saying ex. So we are written here same ex. But when there is only one variable is given, here you have to write 1 upon x. So many times this function and variable we have to use one this and second one this. Okay. So keep it in mind. Log x is equal to 1 upon x. Log x is equal to 1 upon x. In this condition now, log x, log ax. Okay. So here we will go with the 1 upon x and log a, or 1 in the bracket x log a. Okay. Next, trigonometry. When we go with the trigonometry, means here we have to find the derivatives of the trigonometry also. In trigonometry, we are using the formulas like sin x, cos x, tan x, cot x, sec x, cosec x. Okay, so that also is present in this derivative. You have to find the derivatives of the trigonometry variables. Okay, so when this trigonometry is came in your example for the solving of the derivative, its derivatives, then if there is a sin x, then you have to write the derivative as the cos x. Okay, if cos x, then you have to write the derivative minus sin x. Tan x, then sec square x. Okay, keep it in mind. This also asked many times. Now, if there is an inverse trigonometry means 1 upon sin x, dy by dx 1 upon sin x. So in this condition, you have to write 1 upon root 1 minus x square. 1 upon root 1 minus x square. In the case of cos minus 1 or 1 upon cos 1 or cos inverse x, we are written here minus 1 upon root 1 minus x square. So in sine inverse, we are using here at the start positive sign, and in cos inverse, we are using here negative sign. Okay, so numerator is changed with the sign and the denominator will be the same, root 1 upon x square. So keep it in mind, c is, when there is a c, mention derivative 0, x derivative a, ax derivative a, x square derivative 2x raised to 1, root x derivative half x minus half, when derivative when function ex derivative ex, ax derivative log a ax, function log x derivative 1 upon x, log a x, then 1 upon x log a, sin x, then derivative is cos x. When cos x, then derivative is the minus sin x. Tan x, sec square x derivative. When 1 upon sin x or sin inverse x, then minus, not minus, 1 upon root 1 minus x square. 1 upon cos x or cos inverse x, then minus 1 upon root 1 minus x square. Now we will go with the other sum rules. Here, multiplication by constant. Okay, so multiplication by constant in this function is given for making the derivatives, that's CF. So instead of CF, you have to write their derivatives, that is CF dash. Power rule already we are explained, already I am explained about this, x raised to n, so nx n minus 1. Sum rule is there, f plus g. Okay, so derivatives in the bracket dy by dx f plus g. or d by dx f plus g. So here is equal to f dash plus d dash, g dash. Difference rule means subtraction rule, f minus g. So derivative f dash minus g dash. Product rule, f g. So f g dash plus f dash g. F g dash plus f dash g. Quotient rule, f upon g. So quotient rule in this, first of all, make the derivative of the first term. Like here, suppose first of all, I will go with again product rule. So here two terms is given for the derivative f and g. Okay. So first we go with the derivative of the g, that is represented as the g dash, means f dy by dx, d by dx of the g. Plus now go with the derivative of the first term, that is f. So df by dx. Okay. And g will be the remain same. Means first of all you take the second term for the derivative and again first term for the derivative. But in this product rule, instead of multiplication, we will go with the addition. When quotient rule is given there, then you have to go with the subtraction. Now in this, first of all, we have to go for the derivative, use the derivative of the first term, and second term will remain constant, like f upon g. So derivatives of the f, g upon derivative of the g, f upon g square. Okay, denominator square. Now reciprocals rule, 1 upon f. So minus f dash upon f square, minus f dash upon f square. Chain rule. So here in this chain rule, we are using composition of the function. So small circle, that is composition of operator of composition. So f composition g. We have to find out derivatives for this composition, f composition g. Now here how we will go for the find out composition? First of all, find the derivative of the first term, that is the f dash. Okay, f dash composed with g, and then find the derivatives of the second. Okay, and just multiply with that. Chain rule using dash. So f of g of x, f of g of x. So when such a type of the chain rule is given, like the functions is given, first of all, make the derivatives of the g of x, means inside of the bracket, whatever the present term, use that. Okay, so inside functions, first make the derivative and then f dash g of x and then g of x. Okay, first of all, make the derivative of g of x and afterwards make the derivative of the x. So f dash g of x, g dash x. Chain rule using d by dx. So dy by dx is equal to dy upon du, dy upon du minus du upon dx. Okay, so like this way we'll go with the different rules which we have to use in the derivatives. Now let's come to see the example. We will start for the solving this example, then only we can understand how this derivative rule we can apply when solving the example is there. Okay, so first of all, what is the derivative of sin x? So sin x means there is a trigonometry. So in trigonometry, when we go with this trigonometry, what we are seeing here? Yes, trigonometry. So here we are seeing sin x function is mentioned, then we have to go with the derivative cos x. Okay, meaning is there, when there is a sin x, when we have to find out derivatives of the sin x, then the answer is the cos x. But how you written? So you have to write like this. D by dx sin x is equal to cos x. D by dx is nothing but it's a derivative sign with respect with the x variable. So d by dx sin x is equal to cos x. Okay, or you can write like this also, sin x dash is equal to cos x. But generally we are write like this only. Now next one. Next one, that is the, what is d by dx of x cube? What is d by dx of x cube? Now here again, we have to find out derivatives of the x cube. Means which rule we have to use here? We have to use here not product, power rule. Okay, in that power rule, what we are saying? X raised to n. Okay, now here you can see again, which I already given the one example on this, x square I told you. So in this power rule, what is mentioned? X raised to n. So nx n minus 1. Like this way, we have to make the derivatives of the given function. So we will go with this. Now there is mentioned x cube. So you can see here in the x cube, first of all, we will take this 3. Okay, this whatever this 3 is present on the head of the x. So first in answer, you have to take this 3 at this level. Okay, so 3x. Now 3 minus 1. So when we go with the 3 minus 1, what happened? We will get the answer 2. So what is our answer? 3x square. For this, which formula we are using? We are using power rule formula. So d by dx x raised to n is equal to nx n minus 1. So by using this formula, just instead of n, represent or replace the number. At last, we will get the answer 3x square. Now, next, what is d by dx of 1 upon x? So 1 upon x, that is nothing but inverse again. Okay, so x raised to minus 1. We can say that x raised to minus 1 also. Here also, when there is a x raised to minus 1 is came, meaning is there is, we get the formula of the nx x raised to n. Okay, x raised to n. So again, we can use power rule for finding out the d by dx 1 upon x. But of course, when you go for the solving, you have to click at this point. Instead of 1 of x, you can write this, or you can represent this as a x raised to minus 1. So here, nx n minus 1, power rule. So I have written here minus 1, that is nothing but our n. X is the common, minus 1, that is minus 2. So minus x raised to minus 2. So here minus 2 is present, that's why we are written minus 1 upon x square. Okay, so again we are using the power rule. Now here we have to find d by dx phi x cube. Again there we can use as a power rule, or like mention the derivative of the CF. That CF is nothing but the CF dash. Okay, CF dash. So derivative phi f is nothing but phi f dash. C is any number. So instead of C, we are written here this phi. So phi f is equal to phi f dash. We know from the power rule that is the x cube. So instead of n, x raised to n, nx n minus 1. So we'll get here answer 3x square. 3x square. Okay. Now, like this, we will find out the derivative of the x cube. We are find out the derivative of the x cube. Why? You can see here mention is a c and f. C is nothing but any number which here mentioned as the f, and f is, that is x cube. So what here mentioned? You f dash. F dash means what? F dash is nothing but the F dash is nothing but you have to find the derivative of this respective variable. Okay. So first of all, make the derivative of this x cube. So what is that? The derivative come is a 3x2. Then go with the derivative of 5. So at this time, when derivative 5x cube is given, this 5 we have to keep outside. As this also is represented in our formula. So 5, like product rule, if you observe, 5 divide dx x cube. So you know x cube means nothing but 3x square, which is multiplied by 5. So our answer will be the 15x square. Okay. So like this way, when there is a number is given with the s square x cube, you have to find out the derivatives. Now find the derivatives of x square plus x cube. Now here we have to go with the sum rule, addition rule. Okay. In this sum rule, the derivative f plus g, what derivative they are given now? X square plus x cube. We have to say sum rule is equal to f plus g is equal to f dash plus g dash. Derivative of the f, derivative plus derivative of the g. So we can work out each derivative separately and then add them. Okay. So first of all, take derivative of x square. So again, same rule. Okay. Nx, x raised to n, nx minus 1. So we will get answer 2x. Now derivatives of the x cube. So we will get answer 3x square. Understood? So this meaning is nothing but we have to find out the derivatives separately for given variables. So we can find out the derivatives separately by using power rule. Now derivative of x square plus x cube is equal to 2x plus 3x square. Why we are using this plus? Because itself in our sum rule we are mentioned f dash plus g dash. Okay. So f plus g, x square plus x cube is equal to d by dx x square plus d by dx x cube. I hope you are understanding what we are seeing here in this example. Now there is a difference rule. Difference rule means sum rule there is a addition is given. In difference rule there is a given. In difference rule there is a given subtraction. Okay. So what we differentiate with respect to does not have to be x. It could be anything. In this case, v. Means always I say d by dx, d by dx. We are generally use the word d by dx. Okay. But it's not compulsory. Instead of this, we can use other variable also. Like in this given example, in this derivative, they are mentioned the term variable v. So d by dv. V cube minus V4. For this, we have to use difference rule. In this difference rule, f minus g. So derivatives of f dash minus derivatives of g dash. So what is the derivative of f dash? That is nothing but derivatives of d by dv v cube minus d by dv v4. Okay. So d by dv v cube means 3v square and v4 d by dv v4 that is 4v cube. Okay, which I represent again by using the power rule. By using the power rule. So like this way, just put in our this formula. So what I get in the f dash is nothing but derivatives of the v cube. Okay, so that answer is 3v square. So replace f dash with the 3v square, keep the minus sign constant. Then what is the g dash? So derivatives of the v4. So v4 is nothing but 4v cube. So our answer is 3v square minus 4v cube. Our answer is the 3v square minus 4v cube. Okay. Now here you can understand. When we go for the solving the derivatives, everything is depends on the rules only. Like first we are taking this difference rule. Once we know the difference rule, then we will go with the power rule. Okay, then only it is possible to find out the derivative of given respective function. Okay, now we will go with the next sum difference constant multiplication and power rule. Now this example which given in this derivative is the combination of all rules. Like we have to use the sum rule, we have to use the difference rule, we have to use constant rule, multiplication rule, and the power rule. Okay, so one by one we will go. Now example, in this example, what is asked? D by dx, d by d, not x, d by dz in the bracket 5z square plus z cube minus 7z fourth. Okay, and we have to find its derivative. So as I say, first make the separate of the derivatives like our formulas. Okay, so first of all find the derivative. First of all find the derivative of 5z square d by dz 5z square, then d by dz z cube, then d by dz 7z fourth square. Okay, like this way we will get our answer by using the power rule. Then go with our function. What given example? That is d by dz 5z square plus z cube minus 7x 4. Now here 5 into, now instead of z square, here we know by using the power rule, we get the answer 2z. So 5 multiplied 2z, 5 multiplied 2z. Okay. Now plus z cube, instead of z cube, we go with this answer plus 3z square. So I've written here 3z square. Now here again 7z fourth. Okay. So here z4 is nothing but 4z cube. So we are written here 4z cube. But again it multiply with the 7. So when we go for the solving this or just putting the answer, don't change the sign of this. Okay. Keep it same. Keep it same. Then 3z square will be the same. So here plus 3z square. Here 4z cube is present. Okay. So what you will get the answer? You will get the answer 10z, 5 into 2 10z plus 3z square. Okay. Plus 3z square and 7 4s are 28. So minus 28z cube. Minus 28z cube. So here you can see the power rule is also used. Summary rule is also used. Subtraction rule is also used. Difference rule. Constant, multiplication, that all rules we have to use here. Understood? Like this way we have to solve the example of this derivative. What we are done here? First of all, we are using the constant power. We are using power rule. For each term, we are solving this derivative of the respective terms. After that, whatever the answer which we got, that we put in the given equation, and with that, if there is a 5z square, we know the z square derivatives is 2z. So 5 multiplied 2z means there is a multiplication rule we have to apply. So like this 5 into 2z, that is nothing but 10z. Okay. So our answer 10z plus 3z square minus 28z cube. So this is for sum difference constant multiplication and power rule. Next is the product. So in the product rule means multiplication rule simply. Now here asking the derivative for the trigonometry. Asking the derivative for the trigonometry. What trigonometry given? Cos x sin x. Cos x sin x. So derivative function cos x. What is the derivative of that? minus sin x. And for sin x, function is there cos x. Okay, sin x function is there cos x. So like this, the product is given, f is nothing but cos x, f is nothing but cos x, and g is nothing but sin x. Okay, so what I mentioned here, f g dash. F g dash means, first of all, keep the cos x same and make the derivative of the sin x. Makes the derivative of the sin x. So at this stage, we can say cos x d by dx of sin x. Okay, derivative of the sin x plus f dash. F dash means now we have to go with the derivative of the cos x. So d by dx of cos x and sin x will remain the same. Like this way we have to solve this example. So I written here f is nothing but cos x and g is nothing but sin x. So derivatives of the cos x is equal to minus sin x and derivatives of the sin x is equal to cos x. Now derivatives of cos x sin x. So cos x minus sin x sin x. Cos x minus sin x by using our product rule. So what is the answer here? Cos square x minus sin square x. Cos square x minus sin square x. So here, when we use this formula of the product rule, keep it in mind, cos x, or instead of cos x, fg is equal to fg dash plus f dash g. Okay, what we are doing here? F we are kept constant, that is nothing but we are kept constant, that is cos x. We are making the derivative of this gx. Kya hai g? G is nothing but sin x. So sin x derivative is the cos x. So cos x minus sin, it will remain same. Okay. Now here f dash means derivative of the cos x. So derivative of the cos x is minus sin x. Okay, in given formula it's a plus, but when we go with the derivative of the cos x, what is shows? It's nothing but the minus sin x. So we are written here minus sin x. G will remain the same, so we are written same here sin x. Understood? Now just use the cos x multiply cos x, that is nothing but cos square x, and sin x multiply sin x, that is the sin square x. Okay, like this way you have to think and solve the problem. Now quotient rule. Quotient rule, that is nothing but when there is some ratio is given, then we are using this, like fg whole bracket dash. So in this, again we have to use the same, that is first keep the constant same as a g and make the derivative of the numerator, that is f dash, minus make the remain same f and make the derivatives of the denominator upon g square. Okay. So what is the derivative of cos x upon x? Now here we know cos x is nothing but the minus sin x. Cos x is nothing but the minus sin x. Okay, and derivative of x is equal to 1. Derivative of x is equal to 1. Okay, always keep it in mind. Dx by dy is equal to 1. Derivatives of x is equal to 1. Okay, cos, that is the trigonometry, so already you know cos x is equal to minus sin x. Now what they are given? Cos x upon x. Cos x upon x. So derivative of cos x upon x. Cos x upon x. What we will go? X. Okay. Like our formula is given in the quotient rule. Keep the same term which given in the denominator. So I keep here same x and I make the derivative of the cos x, that is nothing but minus sin x. Okay. Minus. Now we have to make the derivative of the x. Okay. So that derivative of x is nothing but 1. And we remain same, here remains same, that is the cos x. So after this, make the common term, that is minus sign, we will take here outside from this x sin x. Okay, so I written here x sin x and I will put this minus sign outside. So when I put here minus sign outside, okay, like this way you have to do bracket plus cos x into 1 is nothing but cos x, and x square remains same. X square remains same. Like this you have to find out this derivative. Cos x upon x, whenever we have to find the derivative of some ratios, go with the quotient rule. So in this quotient rule, what is the mention in the quotient rule? Fg, f upon g, dy by dx of f upon g. So first of all, use this, first of all, make the derivatives of the first numerator minus make the derivatives of the denominator upon g square. Okay, like this way we have to solve. Now next, reciprocal rule. So in this reciprocal rule, what is d by dx? What is d by dx? 1 upon x. 1 upon x. So reciprocal rule says that 1 upon f is equal to derivative of minus f dash and f square and f square. Okay, so minus f dash and f square. Because of this only I told you, please do the formulas properly, then only you can solve these derivatives. So reciprocal rule says that 1 upon f is equal to minus f dash upon f square. Now f of x is equal to x. We know that f of x is equal to 1. Okay, so derivative of 1 upon x is nothing but 1 minus 1 upon x square. So this f of minus f dash means what? Minus x square, minus x, derivative of minus dx by dy. So derivative of x is nothing but 1. So we are written here minus 1 dx by dy. So is equal to 1. Okay, and f square, f is nothing but the x. So just we are written here x. Like this way you have to go with reciprocal rule, which is the same result we got using the power rule also. Using the power rule also. Means in this power rule, how you go then? You can write x raised to minus 1. Okay, this x raised to minus 1. Okay, so what you will get answer then? You will get the 1, x raised to minus 1, that is minus 2. Okay, so x raised to minus 2 means minus 1 upon x square. Minus 1 upon x square. So same answer you will get there. Okay, so if you are using the power rule, then also it is the possible. Like 1 upon x is nothing but x raised to minus x raised to n minus 1. By using this rule also, you can solve this formula or the reciprocal rule. Now we will go with the chain rule. Chain rule, what is the d by dx of sin x square? Okay, d by dx of sin x square. So here in this, there is a 2 terms is mentioned. First is the sin and second is the x square. Means you have to use here chain rule. So in that chain rule, f is nothing but sin and g by x is nothing but x square. So f of g is nothing but sin of g and g of x is nothing but x square. So what is our chain rule says? F of g of x is equal to f dash g of x g dash x. F dash g of x g dash x means first of all make the derivative of sine g. Okay, so first we are doing this. Sorry. First, make the derivative of each term like f dash g. So f dash g is nothing but the cos g. F dash g derivative is cos g. F means what? Sine. What is the derivative of sine g? That is cos g as per our formula of the trigonometry derivatives formula. Then g dash x. So g dash x. So g dash x, that is nothing but x square. Okay, dy dx x square. X square means nx n minus 1. So 2x, 2 minus 1, so 2x 1. Okay, like this way we have to find out individual derivative. After that, put up in this our formula. It will be the easy for the solving. So first f dash g, that is nothing but cos g by x, g of x, cos g of x. Okay, then g dash x. So what is our g dash x? That is the 2x. So cos g of x 2x. Now keep these two outside. So what we will get answer? 2 cos. Now this x multiply with this x. So x square 2x cos x square. 2x cos x square. Like this way we will get answer for given this derivative, which we are done by using the formula of the chain rule. What is the formula of the chain rule? F of g of x is equal to f dash g of x g dash x. First of all, find the derivative of the each term, each variable, like sine is given, x square is given. So sine is nothing but f and x square is nothing but g of x. Okay, so make the derivatives of that. Sine is nothing but cos g x square by using power rule 2x. Then put up in our formula of this chain rule and take it the answer. Okay. Now next, what is d by dx sine x square? So same here again, d by dx sine x square. So here also two terms is mentioned. One is the sine and second one is the x square. And we have to find the derivatives. Now in this derivative, we will go with the dy by dx is equal to dy upon du dx. Dy upon du of dx means derivative of y and derivative of u. Okay, so let's consider u is equal to x square. U is equal to x square and this y is equal to sine. Okay, derivative, first of all find out derivative of sine, that is the sine is equal to cos x, and derivatives of the x square by using power rule, that is 2x minus 1. Okay, so derivative of the sine x square, that is the d by du sine u, d by dx x square. So d by dx sine x square, that is nothing but cos u, and x square derivative, that is the 2x. Okay, so derivatives of the sine x square. So instead of sine, you have to write here cos, and instead of x square, you have to write here 2x square. Okay, so 2 we have to write here, and again this cos x is present, so we are written here x square. Okay, instead of u we are mention here our x square. Understood? So 2 cos x square. I again repeat, we have to find out d by dx sine x square. Consider sine as a y and consider x square as a u. First of all, find out the derivatives of the sine x square. So sine d by du y is equal to sine u. Y is equal to sine u. So d by du, instead of y we are written here u, sine u, derivatives of the x square. Okay. So sine u is nothing but the cos u and x square is nothing but the 2x. Understood? Cos u and 2x. Now we know u is nothing but our x square. Okay. So instead of u, just put up this value x square. Replace u with the x square. So we are written cos x square and we kept here constant 2x. Understood? Now another example of this chain rule, d by dx 1 upon cos x. Okay, 1 upon cos x. When you go for the solving and making the practice, then only you can understand easily. Even you can give the answers orally also. Okay. But before that, you have to by heart the all formulas of the derivative. Then only it is possible. Next, again, we have to use the chain rule. What is d by dx? 1 upon cos x. So now here 1 upon cos x means we can say like this. Here we have to use the inverse rule also. Okay, or we can use a ratio rule also, quotient rule. Now, first of all, we will go make it 1 upon cos x is made up of 1g and cos x. Okay, so f of g is nothing but 1 upon g and g of x is nothing but cos x. Now, whatever I write here g, that is respect with the our given formula. Like here the formula is given of the chain rule, f of g of x is equal to f dash g of x, g dash g of x. Means in this formula, derivative of f of g of x, first of all, find out the derivative of the first term. So f dash means 1 upon g. Make the derivatives of the 1 upon g. Keep the constant g of x same, that is the cos x. Okay. Next, g dash x. G dash makes x means make the derivatives of this cos x. Like this way, we have to solve by using this chain rule. So first of all, let us consider what is f upon g, that is 1 upon g. Then what is the g of x, that is the cos x. Okay. So put first of all solve this or make the derivatives of the 1 upon g, that is 1 minus 1 upon g square. D derivative of d of dx is 1 upon g is equal to minus 1 g square. Okay. After that, derivative of cos x. So derivative of cos x, that is nothing but minus sine x. Minus sine x. Okay. Derivatives of cos x is minus sine x. Now, 1 upon cos x, you have to make this dash is nothing but you have to make the derivative of this 1 upon cos x. So minus 1 upon g of x square into minus sine x. Minus 1 minus sine x, you can write in the bracket upon g x square. So what is our last answer? Minus minus sign will get cancelled and just we will get the answer. Instead of g of x, we can write here. Instead of g of x, we can write here is our main function, that is sine x. Instead of sine x, we are written here cos x. So sine x upon cos square x, because we are consider g of x is nothing but the cos x. So already we are done that all derivatives and we will go with our last answer. So whatever we are replacing, just put up the same, like g of x is nothing but cos x. So cos x square, cos square x. Last answer is the sin x upon cos square x. Okay, like this way we can use here the chain rule. Now, next one again with the chain rule, same. here derivatives, we have to find out the derivatives of bracket 5x minus 2 bracket cube, 5x minus 2 cube. Okay, so first we know the derivative of this now by using the chain rule. First derivatives of the first term, put the second term same. Next again make the derivatives of the minus 2. So f is nothing but, f of g is nothing but g cube. Okay, instead of this 5x minus 2 we are mentioned here g. So 5 of g is nothing but g cube. Okay, next, what is actual g? G of x, that is g of x is nothing but 5x minus 2. G of x is nothing but 5x minus 2. Now why we are doing this? Because we have to find the derivative which given in the bracket. It's mentioned in the bracket and mention this cube of that. Okay, so because of this, first of all, this all term is considered as the g. This all term is considered as the g. Okay, f of g. And then only g of x is considered as the 5x minus 2. The individual derivatives are, so f dash g. So this f dash g, use again power rule, g cube 3g square. Next 5x minus 2. So we know whenever there is when value is there, like c is equal to 0, our first rule. So when there is a c, we have to make it derivative as a 0. So instead of minus 2, we are written here 0. And when there is a 5x is given, we have to represent as the only number, that is 5. Okay, so derivatives of the 5x minus 2 is equal to 5. Now keep it in our formula. So f dash g of x, f dash g, that is the g cube. Okay, g cube. So g cube is nothing but our 3g square. So I write here 3g. Okay, x. So for this x, I make here square like this way. I written here 3g square. Now here they are mentioned g of x. So what is our g of x? That is nothing but 5. So we are written here 5. Now multiply this 5 into 3. So we'll get 15. Okay, 15 g of x square. But what is the g of x we are taking? That is nothing but 5x minus 2. So put now in our main answer 15 in the bracket 5x minus whole square. Instead of g of x, we are written this 5x minus square 2 square. Like this way, we can solve this example of the derivative by using the chain rule, by using the power rule, by using the constant rule, multiplication rule. Okay. Okay, students, thank you very much for attending today's session. I hope you are understanding how to solve the problems of the derivatives. Theory is important, but with that theory, the main concept in this derivative to solving of the examples. Okay. All examples is based on the formulas only. So please do properly the formulas, please by heart the formulas properly, then only you can solve the examples on the derivative with respect to given rules. Thank you very much. Thank you.